Hello everybody, my name is Yazen Ghannam, and I'll be presenting the first half of my team's project proposal for malware and software vulnerability. My partner Thomas Carroll will be presenting the second half. Today, the most common way for a user to authenticate themselves with a computer system is to use text-based passphrases or PIN numbers. So the user creates a unique number or passphrase and attempts to remember it. Many researchers have developed newer methods using biometrics and gestures so that the users don't have to memorize or have an easier way of authenticating themselves. Now, most of these methods, they only use a single input type, and each input type has its own strengths and weaknesses. For example, if you use a fingerprint reader on your laptop, it's very easy for you to use because you always have your fingerprints, you don't have to memorize anything, but it may or may not be difficult for somebody to gain access to your laptop. If they're able to steal your laptop, they can easily gain your fingerprints from your keyboard and possibly use that to break in. So it has its own strengths and drawbacks. Of course, this leads to another issue of many of these methods, they require specialized devices or systems, and a lot of times these aren't available to end users. Good example is facial recognition. Many people don't have access to the cameras and specialized equipment and the computer vision resources to do those kind of things. So for our project, we plan to focus on three input types: face, body and gesture, and audio. And we hope to investigate the combination of these types and hopefully mitigate any drawbacks each of them would have. So we may do 2 out of 3, different combinations of 2 out of 3, and maybe all 3 of them together. So the nice thing about all 3 of these is they can be implemented using the Microsoft Kinect. So the Microsoft Kinect is Microsoft's depth camera sensor for user tracking that's used with its video game system, the Xbox 360. This device is widely available for that user, and similar systems are actually becoming available from other corporations and developers. So hopefully whatever research we're able to conduct using this device in this field will be applicable to future devices in general. So some background and previous research. So each 3 of these types kind of has different flavors. So with facial recognition, one of the flavors is focusing on facial features. And this is very widely researched. This is kind of the mainstream idea of facial recognition. The idea is, we want to recognize individuals, unique individuals, without being sensitive to facial expressions or those kind of things. So the main question you're asking here is, who is this person? Not what are they doing or whatever. Can we recognize each unique person, even if they have a different haircut or they're smiling or laughing or these type of things. So this is a very popular research area, and if you have any experience in computer vision, you'll find that a lot of computer vision applications go into this particular field. Now another flavor of that is actually recognizing facial gestures. So here, here the goal is to actually recognize the expressions. So is the person smiling, is the person frowning? We're not worried about who they are, we're just worried about what are they doing. So, do they have their eyebrow raised and these types of things? Where are they looking? That kind of thing. So the Microsoft Kinect SDK actually has this available. This can be extended, of course, to do the unique facial authentication, but at its bare minimum, it will track specific points on the person's face, and you can go from there. Now, with gesture-based authentication, one of the flavors is using handheld device. So for example, the paper that we're citing here, the authors use a cell phone. So many modern cell phones, of course, have accelerometers and different devices in them that allows you to track their position in 3D space. So with this flavor of authentication, the user actually physically manipulates a device, and then the device records the data and tries to send it to a system to match that data to a gesture. So I usually try to match the data to a certain template, and try to deduct the gesture from that. So this is a very commonly used method. Cell phones use this, tablets can do this. The Nintendo Wii, the PlayStation Sony PlayStation Move. All of these have accelerometers in them and types like that, so you can the interaction with the device can actually be translated to the data. So this is becoming very popular. But what if you don't have a device? What are you going to do? Can you do something without a device? And that's where this flavor of this type of input comes in, where you're actually using the user's body. So here the user performs hand and body gestures, and the device, cameras, and sensors track the user and gathers skeletal data, gathers depth information, and uses that to deduct a gesture. So the idea here is it's kind of similar to secret handshakes and gang signs. And that's actually the example that's given in our first paper here, Bro Off, where certain people, they have secret handshakes with gang signs that only other members of their group will recognize. And that's the goal with this type of research. So an example of this is the Microsoft Kinect. The Kinect is actually this type of sensor. And so these two research papers use the Kinect. Now the nice thing about the Kinect, as mentioned earlier, is that it's low cost, it's widely available. So you'll see a lot of researchers are starting to use it. Also because Microsoft has released an SDK for it. So there's a lot of examples in code out there now that's only been released in the last couple of years for this device. So you'll see a lot of these research papers are fairly new and fresh. Now the third type is voice-based authentication. So here there's of course two flavors. The first is actually trying to identify a unique voice. So here you want to recognize an individual based on their voice. You don't want to worry about what they're saying or that type of thing. You basically, from the person, you create a voice print, and that is stored and matched. So in this area, a lot of machine learning techniques are used to kind of learn the individual person from their voice and to match. This isn't necessarily what we're going to be doing for our project. We plan on using more of this passphrase authentication. So here the goal is to recognize keywords. You're not worried about who is or if the person is unique or who is saying it, but what are they saying? This is available in the Kinect. So the goal here, or basically the method here, is the developer creates a grammar, and when the user uses the system, the speech engine matches the audio input from the user to the developer's grammar. And the speech engine is already developed by Microsoft. It's already been researched, and they have different engines for different locales. So for example, they have an American English, US English, British English, or Great Britain English, Australian English, German, and so on. So they've already trained the system to recognize words based on the speech of people in these different locales. So we plan to integrate this with our system. Hopefully a combination of all three of these will lead to something new and fresh and interesting. So from here I'm going to hand it off to my partner Thomas Carroll to take you through the rest of the presentation. Thank you.
My name is Thomas Carroll, and I'll be covering the rest of our presentation, including our research questions and our research methodologies. First, we want to ask for this project, can the combination of two or more of these authentication methods result in a more secure authentication system? Specifically, we're talking about facial recognition, voice-based authentication, and gesture-based authentication. Second, we want to ask, will imitators be able to crack the system by mimicking the gestures? So if I record my gesture as raising my eyebrow and someone else knows that I've recorded that gesture, can they come along and try to mimic that gesture to hack into the system? Third, how intuitive, relating to natural user interfaces, can a combination of these authentication methods become versus traditional methods? And here we have three examples of traditional methods. Probably the most common is using a password via a keyboard. In the middle, we have less common, using a fingerprint scanner. And on the farthest right, we probably have the least used, which is an iris scanner. And that's probably the most secure and most intuitive, but also the most expensive. Fourth, can facial gestures be incorporated in a secure authentication system in addition to body gestures? Specifically, will facial changes affect accurate identification? In other words, in 10 or 20 years, when I've aged significantly, or if I grow a beard, or if I swap out my glasses for contacts, will the system still be able to identify me correctly? For our research methods, we've chosen to follow the concept implementation methodology, otherwise known as the proof of concept. And we're going to use the Connect for Windows SDK, first off to identify the user using 3D facial recognition, second to match the user's gestures to a pre-recorded set of gestures, and third we want to use voice passphrases for authentication. Next, we want to conduct experiments to find the balance of user feedback during authentication. Specifically, we want to provide gesture password strength, much in the way that you do on a website. It'll tell you whether your password is weak, medium, or strong. Second, we want to provide out-of-range feedback if they're too close or too far away from the sensor. Third, we want to let the user know if there's noisy data going on in the background, such as a cat or a pet. And fourth, we want to provide feedback for separation of authentication stages. So when you're recording your gestures, you probably would do your body gesture first, then your facial recognition gesture, and then your voice passphrase. We want to conduct experiments using different human subjects to determine the system vulnerabilities with the studied approach. Specifically, we want to see how hackable the system is. And here are our citations. That concludes our presentation. Thank you.